Comes on everyone. Great. So this was the last problem that we did. The tetrahedron. Hope everyone has gone through the notes. Okay, this is another good one that we did. Angle between A plus B to A minus B. Great. Let's go ahead with one more. Others do keep your cams on. So we have force to y minus 3j plus moves from point 1 comma 2 comma 3 to point B, which is minus 1 comma minus 3 comma minus 2. Find the work done by the force. Now the formula for work done is this: F bar dot S bar. S bar is your displacement vector. So you're going from A to B. So that is simply F bar dot AB bar. That is the formula for work done. F bar dot S bar. So you already know how to do the dot product. Since you're going from A to B, A is the initial, B is the final. So the vector becomes AB bar. If you go from B to A, it will become BA bar. Do keep your cams on. I'll give you a minute or else I'll start removing you. Prisha, you won't get a... Okay, that is 9 joules. Okay. I thought this JCap for a moment. Yeah, fine. Must be right. So how to do this thing? Get AB bar and get the dot product. Straightforward, right? That thing you guys know already. Right, Ishi. So let's find AB bar. I'm sure everyone knows that. AB bar, you're going from A to B. B is the final. So minus 1, minus 2 I cap. Minus 3, minus 2, minus 5 J cap. And minus 2, minus 3, minus 5 K cap. And this is the force. So you want to get the dot product, F bar dot AB bar. How to do the dot product? Multiply the I coefficients, which is 2 into minus 2. Multiply the J coefficients, minus 3 into minus 5. Multiply the K coefficients, 4 into minus 5. That's minus 4 plus 15 minus 20. That would be minus 9 joules. Easy? All clear with this? Great. Next one. We have a vector A bar, which is AX I cap, AY J cap, and AZ K cap. This vector A bar makes an angle alpha with x-axis. Angle beta with y-axis. gamma with z-axis. So these angles, right? Cos alpha, cos beta, cos gamma, these are called direction cosines. We will talk about in more detail. These are called direction cosines. Find sine square alpha plus sine square beta plus sine square gamma. And just to give a little more context, the picture will look something of this sort. So if you're taking x, y, z, and let's say if this is your vector a bar. So if you take an angle with the x-axis, so this angle is alpha. If you take angle with y-axis, this is your beta. The angle with z-axis is this gamma. So it's a three-dimensional thing there. Do one thing. Let's first find cos alpha, cos beta, cos gamma. Start from there. Let's find alpha, beta, gamma. So the vector a bar is forming angles alpha, beta, gamma with x, y, z axis. Find alpha, beta, gamma. Let's start from there. Now, let me ask a simple question. If you're confused like how to start, suppose if I give you a vector a bar and I give you a vector b bar, and if I ask you find angle between a bar and b bar, what do you do? We do the dot product. Remember, a bar dot b bar is mod a mod b cos theta. Isn't this how we find the angle? Now I'm asking you to find the angle with x-axis, y-axis, z-axis. So along x-axis, which vector is there? I cap, isn't it? So indirectly, am I not asking you find the angle between a bar and I cap, a bar and j cap, a bar and k cap? Do you guys agree with that? If you find the angle between a bar and I cap, isn't that the angle between a bar and x-axis? Right? So indirectly, that is what is being asked. So if you take a vector along x-axis, to be more precise, unit vector along x-axis is I cap. Now the question has become like this. So alpha is the angle between the vectors a bar and I cap. So how do you find that then? So ax bar, a bar dot I cap is mod a bar mod I cap cos alpha. So what is a bar? That would be ax I cap, ay, j cap, az, k cap dot. I'll show you one whole thing. What is mod a? Root over ax square, ay square, az square. Mod I cap is 1 cos alpha. So when you do the dot product, you know what to do. Only I components will multiply. You end up with ax by bring that thing down here. Ax square, ay square plus az square is equal to cos alpha. So you want I'll write the whole thing for once. There, we get cos alpha like this. Is this making sense, everyone? Right, Prisha? Nee, Ahana, that is wrong. Nee, Rohit, wrong. All clear with the step? Same thing we will do for y-axis. So for y-axis, this will become j cap. So beta will be the angle between a cap and j cap. This would be j cap. This would be mod j cap. And this would be cos beta. This would be j cap. You do the same story here. You end up with cos beta, which is ay by root over ax square plus ay square plus az square. I think by now you understood the reasoning. We can do the same thing for j cap also. You end up with cos gamma will be az by root over. There. You get your cos alpha, cos beta, cos gamma. Right, Rohit? All clear with this? Now, once you got all three, if I do cos square alpha plus cos square beta, cos square gamma, you end up with ax square by ax square, ay square plus az square. Ay square is ax square, ay square, az square. This would be az square by ax square. Az square is equal to 1. So this is a pretty good relation, cos square alpha. That means you take any vector, right? And if you get the angles alpha, beta, gamma, the cos ka thing will be always 1. Now you can simplify this. You can write cos square alpha is 1 minus sine square alpha. 1 minus sine square beta. 1 minus sine square gamma. This is the thing which was being asked. Sine square alpha plus sine square beta. Sine square gamma is equal to 2. That's your answer. All clear with this? So the main thing is to realize when you said find the angle with x-axis, it is as good as finding an angle with an I cap. All clear with this? So these angles, right? This cos alpha, cos beta, cos gamma are called direction cosines. So we can actually use them. The reason why we call them direction cosines is because of this. If alpha, beta, gamma are angles, made by a bar with xyz axis, then you can write a cap unit vector as cos alpha I cap plus cos beta j cap plus cos gamma k cap. So basically these cos functions will give you the direction of a vector. That's why we call it a direction cosine. Meaning, how did we get this? You can simplify it and check it out. See, if you just expand this, cos alpha is what again? Ax I cap, ay j cap, az k cap. All of them have same denominator, which is root over ax square plus ay square plus az square. This is nothing but a bar by mod a bar. Making sense? So if someone gives you the angles, you can find the unit vector. So we call this thing direction cosines. So you can play around. So if alpha, beta, gamma are the directions, angles, then you can get the vector. All clear with this? So that is one new terminology you heard today, direction cosines. Because these are showing the directions, the cosine functions are showing directions, we call it direction cosines. Any doubts on this? Clear, na, Radhika? Manav? Clear? Shrikant? Tanmay? Okay. Let's go ahead. Ahna, Ananya, clear? Dave? If alpha, beta, gamma are angles, made by a bar with xyz axis, and if alpha is to beta is to gamma is 1 is to 2 is to 1, Find alpha. I can even ask find a bar. So yeah, I can ask you a cap. But if you got alpha, you'll get everything. So there is a vector a bar which is making angles alpha, beta, gamma, and these angles are in the ratio of 1:2:1. What are these angles? Find alpha, beta, gamma. Yeah, this is more of a max question now. Give it a try. Any answers? Just now we use the result, right? Cos alpha, cos beta, cos gamma. We have to use that. So we know cos square alpha, cos square beta plus cos square gamma is equal to 1. And you're saying alpha, beta, gamma is 1:2:1 ratio. So alpha is equal to gamma. So I'll write everything in terms of alpha, okay? So gamma is alpha and beta is 2 alpha. Substitute here. Cos square alpha, cos square 2 alpha plus cos square alpha is equal to 1. This would be 2 cos square alpha plus cos square 2 alpha is equal to 1. Anyone remembers what is cos 2 alpha? Basic math. Where are you? Here. Cos 2 theta. Look at here. So cos 2 theta is 2 cos square theta minus 1. Page 15. Cos 2 theta can be written as 2 cos square theta minus 1. So if you bring that thing this side, I can play like this. 2 cos square alpha minus 1 plus cos square 2 alpha is 0. So 2 cos square theta, this would become cos 2 alpha plus cos square 2 alpha. I can take out cos 2 alpha common. That's why I said it is more of a max question at this point. Take out cos 2 alpha common, you end up with 1 plus cos 2 alpha is equal to 0. So we have either cos 2 alpha is 0 or cos 2 alpha is minus 1. If cos 2 alpha is 0, we get 2 alpha is 90 degrees and we end up with alpha is 45. That's one possibility. Or if you take cos 2 alpha is minus 1, then 2 alpha is 180 degrees and then alpha is in 90 degrees. Both are right. So either 45 or 90, both will satisfy this condition. Yeah. Let's check and see whether they really satisfy. So you're saying cos square 45, that would be half. Cos square 90, that would be 0. Cos square half, yeah, it's satisfied. Then cos square 90, that's 0. Then this would be cos square alpha, that's 1. And yeah, that also satisfied. Yeah, it works. Clear this? So if it is a more than one choice question, you mark both of them, 45 and 90. So yeah, like I told you, this is an important formula. This will keep popping up. You see, I didn't even go to the next chapter and this thing already came twice till now. That's what I said in the beginning. It's very important. We kept some 2, 3 stars, 2 stars. So that's an important one. All clear with this? Yeah. In your class, if they have started trigonometry, this is still a small one. Next one. Now let's see how they'll ask this in physics. They'll not the exact one, but how will dot product be in physics? Let's say we got a mirror. Like I said, vectors is just nothing but a tool, right? It will come as a part of something else. You will never get a question of pure vectors in physics. So we got a mirror. So you send a light ray here, it hits the mirror and bounces off. So r cap is a unit vector along the reflected ray. I cap is a unit vector along incident ray. This is your n cap, unit normal vector. So this is a vector perpendicular to the mirror. This you studied in school, right? Light ray hits a mirror and bounces off. So using this information, right, you need to find the relation between I cap, R cap, and N cap. Meaning, if I give you I cap and N cap, you should be able to tell me R cap. Now, see, in two-dimensional, right, it is really easy. On a XY plane, it is easy to figure out the angles. But if I suddenly say there is a mirror at a weird angle and the light ray is coming at some other angle in three-dimensional, it becomes very difficult to solve. And that is when vectors becomes really useful, when you're seeing things in 3D. Find relation between I cap, R cap, N cap. Let's think for a minute or two how to proceed, then I'll show you. This is a little difficult one. More than a difficult one, it's like a standard model. This is a question in ray optics, the light. This is how they'll frame questions. Dhruv, your cam is completely blank. I can't see you. How do we approach this? I cap, N cap, back. Why it is 0? You should give a reason. Okay, let's see. Fine, none. You think? Listen. We have to do little, things moving here and there. So this is your vector there. This is your r cap. Remember, this is your I cap. So I will push it forward. This would be your I cap. I can do that, right? I can always push the vectors forward. I'll keep them tail to tail. Great. Now let's take this angle to be theta, this angle to be theta. Now R cap is nothing but 1 unit. So this is unit 1. If you drop a perpendicular, what will be this length here? That length will be 1 cos theta. Agreed? So this length also will be 1 cos theta. Similarly, this length also will be 1 cos theta because it's a unit vector. Great. Now let me just redraw them again. So this is your R cap. This is your I cap. And this black one is a vector whose length is 2 cos theta. And can tell me in which direction is this vector? Isn't this vector and the black line both are parallel? So this black vector is in the direction of n cap. Yeah, but the magnitude is 2 cos theta. All clear with this? So far clear with the geometry what we did? And now here I can write this thing as triangle of vectors. Look at this. If I go from here to here, here to here, and then come back here, that is if I go I cap plus 2 cos theta n cap, and if I go reverse of r cap minus r cap, I come back to the same point, 0 cap. Agreed? So this is a 0 vector. So I can write r cap as I cap plus 2 cos theta n cap. Clear so far? Then again, coming back to the picture, let's do a little more there. So this was your n cap. Remember, this was your I cap. So I will push it forward. So this is your I cap. This was your angle, theta. This angle would be, or I will just keep it like this only, wait. This was your I cap. So when I reverse this, if I reverse this vector, won't this become minus I cap? That's better. I will reverse the vector. So this will become minus I cap. Now, if I do the dot product, minus I cap dot n cap will be mod of minus I cap. Mod of n cap is cos theta. Now, why am I doing this? To find cos theta. This would be minus I cap dot n cap, and this is 1 and 1, so this is cos theta. Now, getting back this thing again here, so we have r cap is I cap. I'll write this down if you want again. Now bring this cos theta here and substitute here. You end up with r cap is equal to I cap minus 2. Cos theta is replaced by I cap dot n cap into n cap. There. This is the relation between them. And which you should definitely remember this. Exam may, if you can derive this in less than a minute, great. Or else you need to remember this. Again, see what we did. Step 1, this I bar which is here, I pushed it forward. I created a triangle like this. I found the length of this line, that is 1 cos theta, 1 cos theta, 2 cos theta. But that is in the direction of 2 cos theta n cap. Then I said, this total triangle sum must be 0. But be careful here, r cap is pointing towards that side. So I have to reverse it. Makes sense. And then I got r cap here. And then the problem I faced was cos theta because theta is not given in the question. I need to get everything in terms of r cap, n cap and I cap and n cap. Then I said, okay, I will reverse I cap. And then I got a cos theta from here. I took it and substituted it and I ended up with this. Note down that formula. I'll give you a question. You will see how to use this. So I cap minus 2 times I cap dot n cap into n cap. So remember, I cap dot n cap is a scalar quantity. you should definitely try to derive this on your own. So tomorrow after the, take a rough paper and just try to scribble it. So copied? Any doubts on the derivation? This is how they'll frame questions in the exam. Vectors will come like this. And the best part you saw, in the whole formula, there's not a single number. Great. So this is how they'll frame a question, say. I'll put it just as an example. I'll put 32. Let's say the incident ray is along 2I minus j plus k. And normal vector is along I plus j minus 2k. Find the unit vector along the reflected ray. If it is 2D-dimensional, right, you can still draw a picture and figure out the answer. Once in 3D, you're gone. And be careful here, they didn't give I cap and j cap, they gave I bar and n bar. But the formula had all I caps, so you had to convert into cap first. And this thing, right, gives you the unit vector only, it does not give you the actual vector. Find the unit vector along the reflected ray. There, let's get this. It is just formula substitution. There's nothing to think. You can note down the formula in case you didn't. So I cap minus 2 times I cap dot n cap into n cap. So get I cap, get n cap, put in the formula, you'll end up with an answer. This is how they'll give a question in the exam, and you'll be wondering like how to approach this. If you just want angle, that is fine. If you want I cap, j cap, k cap, it's a mess. Okay, let's find I cap first. 2I minus j plus k cap by root 6. I plus j minus 2k root 6. So R cap is I cap minus 2 times I cap dot n cap into n cap. That's your formula. Substitute here. 2I minus j I dot n will be 2 minus 1 minus 2. That would be minus 1. By root 6 will be 6. And n cap will be I plus j minus 2k by root 6. That would be 1 by 3. So take out 1 by root 6 common. You end up with 1/3 of I plus j minus 2k. Brute force solving, there's nothing there in this. So 1 by root 6, that's 2 plus 1 by 3, 7 by 3. Just check the calculations. I could have goofed up. Minus 1 plus 1 by 3 minus 2 by 3 j cap. 1 by 3 k cap. Anyone got the same? Or did I mess up somewhere? Mm, mm. Okay, Anish got the same. Anyone else? One more confirmation. Yeah, the rules about it. I think, yeah, that should be right. Mostly maybe then. But all got the steps. Not difficult, right? So once you know the formula, it is not difficult, but you should know the formula. This is how they'll play around with this. So you might think like, oh, this is looking weird. Wait till you actually see later on. So there was a thing called dipole karke. We did a vector form for it. This is the vector form for a dipole. It looks like this. K by r cube 3 into something called p bar dot r cap into r cap minus p bar. This is a pretty common notation. Huh? Matlab, it might look tough now, but don't get scared and all, understand, okay, this is how it has to be done. Once you see 3, 4 models like this, right, then you'll get used to it. It is always like that. I'm pretty sure first time when you saw I cap, J cap, K cap, it must have sounded a little weird. But after that, now you feel like, okay, I cap, J cap, I do understand types. So this is another chapter called collisions. So this here also look at the final answer, how it looks. The final answer is this: v square minus v bar dot u bar by u square minus v bar dot u bar. So this will not be the first time, or this will not be the last time. This will keep popping up. So as we go on every chapter, you will keep, making a collection of all these things. I think by the time we finish up a portion, we'll be doing around 1400 to 1500 questions. In that, you will find good ones like this, maybe around 200 to 300. That's the whole point. Don't think like, oh, I won't remember and all. See, if you don't remember, you won't get speed. You need to know your standard models. When you know your standard models, then the higher level questions will come. Most people have this misconception, ratta nahi marna hai. Yeah, you should not only by heart without understanding how it is derived. So remembering standard results and basic derivations is like a raw material. Without raw material, you can't think in space. So that's a misconception kids have, like, oh, I won't remember anything. Then you'll never improve in your speed. You can't think better. Anyway, that is one thing. All clear with this? So that's a bit about dot product. The next thing is a vector cross product. This is a different one. This we will encounter a lot from rotational mechanics. So mostly we won't deal with this in the first 3, 4 chapters. It might not come much, but after that it comes a lot. So what is this again? Like I said, this entire vectors, right? We have seen things and we made it up. So same way, vector cross product, right? People observed there are certain vector quantities which depend on two vectors. And sine of the angle between them. If you remember, the dot product was cosine of the angle. Right? So this is what people seen actually. So you must have heard this word torque, moment of force. Tau, this is given by r into f into sine theta. R is the distance from the axis. I will not get too much into it. Don't worry, we'll see later on. F is your force. Then people saw a magnetic force. So this F is given by Q into V into B into sine theta. Q is charge. That's a scalar quantity. V is velocity. That's a vector. B is the magnetic field. And so if I give you one more example, angular momentum. This, if you've done your chemistry atomic structure, you must have heard this. Angular momentum is quantized. Heard that word in chemistry? Atomic structure. If you're not, it will come soon. Angular momentum symbol is L, which is given by m into r into v into sine theta. So m is mass, r is the distance, v is your speed or velocity. So people saw these things like, it is popping up everywhere. Then they said, okay, why don't we just make up something like this, just like dot product? And then we started calling mod a bar, mod b bar, sine theta as a cross b bar. And actually, we had to put a vector also. We'll talk about that. So we call it a cross b bar. So there. So a cross b bar means mod a bar, mod b bar, sine of the angle between them into an n cap. So what is this n cap? This n cap is a pseudo vector. Remember pseudo vectors? These are the vectors which are out of the plane. They will give you the sense of rotation. We did a discussion on that. So you need pseudo vector which is perpendicular to both a bar and b bar. We will talk about it in a bit. But there, this is a dot product. We have created something like this. Clear with this so far? Then, so this formula becomes torque is equal to R cross F bar. This formula becomes F is equal to Q into V cross B. This formula becomes L bar is equal to M into R cross. So this is how you will see the formulas later on in terms of cross. Any doubt so far? No. What is exactly A cross B? How do you define this? So if this is A bar, this is B bar. So this is how you can read. When you say A cross B bar, meaning if A vector rotates towards B bar, so rotate A bar towards B bar, right? And use the right hand thumb rule for direction. So how will the vector be? So if you rotate A towards B like this, then the vector will point upward, isn't it? A cross B. Is that making sense, everyone? So if you rotate A towards B, you will get A cross B. Remember that Kruka example? Look at this again. If this bottle you can see, so if I rotate this direction, suppose let's say if this is A and this is B. So in front of you is A and this is B, the left. Now if A rotates towards B, meaning if I rotate this way, you can see if I'm rotating this way, the cap comes out. That is the direction of your thumb, isn't it? If you rotate this way, thumb comes out. If you rotate this way, the cap goes inside. It becomes right. You guys remember this? The pseudo vector, we discussed this, like a right hand screw. Similarly, if you say B cross A, means if the B vector rotates towards A vector, then the vector will point down. So the rotation is given by the curl of the fingers and the thumb indicates the direction. So Where did we do this? Here. This is page number 78. That we have discussed in detail the direction. All clear with the direction part? Next thing, so how do we calculate this? So the first one, what happens if you take I cross I? I cross I is mod I, and the angle is 0 because they're parallel vectors and sine 0 is 0. Similarly, J cross J is also 0. K cross K is also 0. So if you take a vector and do a cross product with itself, you always get a 0 vector. That's because they're parallel vectors and theta becomes 0. Be careful in case of a dot product, a bar was a square. So dot product was different. In a cross product, you become 0 there. But what happens if you do the other ones? Let's say if I do I cross J. Listen, think of like this. Your right hand side, you can do it with your right hand side is x-axis. Okay, stretch your right hand, that's your x-axis. In front of you is your y-axis. Your ceiling up is z-axis. Got the directions? Your right side is x, in front of you is y, and up is z. Now I cross j means what? Your right hand, which is on the x-axis, is moving towards your y-axis, isn't it? You're rotating towards the left. Then how is the direction? Thumb is pointing up. Everyone can see that when your right hand rotates towards front, the direction is this way. Thumb is pointing up. So what is I cross j? I cross j is k cap. So when I goes towards j, you get a k cap. Similarly, if I do j cross k, what is this direction? Again, remember j is in front of you, z is up. So you're going this way. The y-axis is rotating towards z. So thumb is pointing towards x-axis. So j cross k is I cap. K cross I cap. So your up is z-axis. It is rotating towards x. So you're rotating this way. Your up is z and rotating this way. So that's j cap. Easy way to remember. You can remember like this: I cap, j cap, k cap. If you rotate from I to j, you'll get k cap. If you go from j to k, you'll get I cap, and k to a, j cap. This is the positive cycle. If you rotate in this direction, you'll get all positives. Similarly, I can make a negative cycle. If you go this way, you'll get all negatives. Meaning if I do j cross I, it is minus k cross j, minus I cap. Then I cross k is minus j cap. I hope all are clear with the directions there. A cross b bar is minus b cross a bar. They're not equal. A dot b was equal to b dot a, not here. A bar cross b plus c bar is a cross b bar plus a cross c bar. Now we don't have vector triple product. Suppose if someone gives you a cross b cross c bar. This is given by a dot c b bar. We don't need it. I have never seen this in physics. B dot C bar into A bar. In max, they will teach you. But okay, just in case. Clear with the directions, everyone. So how do you find, the cross product between two things, two vectors. One thing is a brute force, okay? I can just multiply everything and I can figure it out. The second thing, there is a technique, right? Matrices. So I will teach you that also, important. But first, let's see the brute force method, just in case. So we have AX I cap, AY J cap, and AZ K cap. Let's say B bar is BX I cap, BY J cap, and BZ K cap. And someone asks you to find A cross B bar. So what we do, take AX, multiply BX, BY, BZ, take AY, multiply BX, BY, BZ, take AZ, multiply BX, BY, BZ. In total, you will get 9 terms. So when you do this, you end up with AX, BX, I cross I, AX, BY, I cross J, AX, BZ, I cross K cap. This is boring, but yeah, we have to write. So then in total, you'll get 9 terms, AZ, BX. Don't write this. I think it's fine. Like I'll show you the determinant one. That is the thing which we'll use most of the times. This method is fine when you're doing only, let's say, if you have only I caps only, right? No K caps, like then it is fine. Up to you, matlab, whichever. But I don't recommend this because there's a good chance you'll mess up one minus and somewhere and the whole thing will go for a toss. So you can clearly see I cap 0, J cap 0, K cap 0. I cross J becomes K cap, I cross K becomes minus J cap, J cross I becomes minus K cap, J cross K is I cap, K cross I is J cap, K cross J is minus I cap. Bring all I caps together, you end up with AY, BZ minus AZ, BY into I cap. Bring all J caps together, AZ, BX minus AX, BZ, J cap. Bring all K caps together, AX, BY minus AY, BX, K cap. This is how you can do. You just multiply everything and finish it off. Clear with this? This is one way to handle this. But for this, you need to know what is this I cross J, J cross K. You should know this stuff. In case even you forward that, like I showed you, right? You can put X, Y, Z and rotate and check the directions anytime. Any doubt so far? Vector cross product, there's nothing. If you know how to calculate the cross product, the questions are quite straightforward. Unlike dot product, right? We really don't have too many variations on this. Now, how to do this thing? We have something called determinants. So first, let's see that. Now, again, completely mathematics. So we are not going to ask like, how did we get this? What is the reason? You have a full chapter in max. But quite an important thing. Matrices, when I learned, I used to think it is a boring chapter. Yeah, I still think it is boring, but your entire computer architecture, right? If you see this AI programming and everything, it is actually based on matrices. Tomorrow, when you study traffic, let's say you're a civil engineer and you're studying traffic. How do you teach a computer how to study traffic? So I'll show you the determinant and then we'll go ahead. So a simple determinant, right? We'll take a 2 into 2 matrix. So this is called a 2 into 2 matrix or 2 into 2 determinant, whatever. So there are 2 rows and 2 columns. So let's say if you have A, B, C, and D. So the answer for this is take A and D, multiply them, take B and C, multiply them, and subtract them. A into D minus B into C. So if someone gives you a determinant like this and asks you what is the value for this, see, look at this. Suppose if I had 1, 2, 3, 4. So this box, whatever is this matrix ka value is, multiply 1 and 4, multiply 2 and 3, and subtract them. So 1 into 4 minus 2 into 3. That is minus 2. So the value of this determinant is minus 2. That is an operation, okay? That is how a matrix works. Matrices are actually made of, simultaneous equations. So let's not get into this. But 2 into 2 is clear. If I give you a 2 into 2, how to solve it? Multiply AD first, then multiply BC next, diagonals, and then subtract. How do you solve a 3 into 3 matrix? Let's say if you have 3 into 3 matrix. So the first thing that we do, step one, put a plus, put a minus, put a plus. We have to alternate the signs. Step two, after putting plus, minus, plus, choose the first term. When you choose AX, you remove the first row and you remove the first column. You have created a 2 into 2 determinant here. So this will give you, so you are taking plus right here. So this is plus AX, and that is the operation, that's how it works. So we take plus AX into, now we are solving 2 into 2 determinant, which is BY, CZ minus BZ, CY. So this has taken care of the first item. So when you take AX, uska determinant is this. That's the operation for that. Then step three, remember plus minus plus. Now we will take AY. So when whichever one you take, you remove that particular row and particular column. So you remove this column and this row. Now again, you're left with a 2 into 2 determinant. So every time you cancel one, you'll get a 2 into 2. So this would be minus AY because you are starting with a minus sign there, minus AY. That's BX into CZ minus CX into BZ. Yeah, this looks more confusing, but this will save you from little sign conventions and all. This is plus minus plus. Now we will choose AZ. This is gone, this is gone. So we will do these two. You get AZ into BX CY minus BY CX. You got the three terms. Now add all the three terms and that's your answer. So for this, the answer would be AX BY CZ BZ CY minus AY BX CZ minus CX BZ. You'll get used to it. AZ BX CY minus CX BY. Yeah, that's how you get the steps. Clear what we did? Step one, plus minus plus. Step two, choose the first symbol, cut off the row, cut off the column. You got a 2 into 2. Yeah, we have to do like this. And the second one, take AY, cut off horizontal, vertical. Cut takes it. So you get total 6 terms, like 3 terms like this, add them up and you're done. Clear with the operation? So I'll give you one. You just tell me what is the answer. Let's get used to this determinant thing. So let's say 1, 2, minus 1, minus 1, 3, 1, 2, 1, 2. What is the answer for this? Try, get it, give an answer. There's nothing to think. You know the steps, you've put it, you get it. It's a tool. Okay, someone got 10, 8. You have two different answers. Anyone else? We have two different answers, 8 and 10. We have 20. Three different answers. 20. Okay, we have two 20s. Okay, let's see. I'll write it down. Let's see whether you got the steps right. So this is plus, minus, plus. So I'll take the first term, 1. So then this is a matrix, 3 into 2 and minus 1 into 1. Please check. Second one, I have to take minus 2 because that's a minus 2 there. So this and this I'll cancel. So this will be 1 minus 1 into 2 minus 1 into 2. Then that is last one plus of minus 1, and then that is minus 1 into 1 minus 3 into 2. Yeah, just be careful with this thing. 6 minus 1, that is 5. Minus 2, that is minus 2 minus 2 minus 4. That is minus 1 into minus 1 minus 7. That is 5 plus 8 plus 7. That's 20. Yeah. All got this? Clear? Easy, right? We will do a few more, but take a break. Come back by 9:42. We'll continue from here. Any doubts so far? Anyone not clear with anything? You can ask. Go, take a break. Come back in 10 minutes then. Thanks on everyone. Let's start off. Let's see one more example. Let's get this. Now, in a matrix, right, you can put even a vectors inside a matrix. That's the one of the best part. Let's see if you have I cap, J cap, and K cap. There, let's get these two. Okay, minus 25. What about the second one? Let's see the first one. Plus, minus, minus. Keep doing others. Let's see if you can verify your answers with me. This would be 3, 4, 3, minus 12, plus 2, minus 6, plus 1. Minus 4, plus 4. That is gone. Yeah, it's, minus 25. I hope you don't got minus 25 for the first one. Same logic here, plus, minus, plus. So the first term will be plus I cap. So instead of a number, you'll put plus I cap. That's the only difference there. And this will be minus 3. Then this will be minus 2. This will be minus j, that will be 2 minus 1, and this will be k, and this is 4 plus 3. Minus 5i minus j plus 7. Okay, check your answers. Minus 5 minus j plus 7. Yeah. Anyone else got the same? Yeah, she got it. Radhika got it. Easy, got the stuff. So this is called a 3 into 3 determinant or a matrix. So just a mathematical technique. We will keep seeing this. Keeps coming wherever you see cross product. This is one of the way to figure it out. Great, but what does this cross product actually signify? If you remember in a dot product, it gave you the component of one vector in the direction of another vector. So the physical significance here is so consider a parallelogram with A bar and B bar as two sides. Now, in this parallelogram, you can clearly see the opposite side of this. This would be b sine theta. Now, anyone remember the area of a parallelogram formula? Base into height. Remember? So the area of a parallelogram is nothing but the base into height. So here the base is a and the height is b sine theta, which can be written as a cross b. Come mod. So the vector cross product gives you the area of a parallelogram formed by a bar and b bar. Suppose we want area of a triangle. So now in this parallelogram, if you just take half of it, that will be a triangle. So area of a triangle formed by the two vectors is half of the area of a parallelogram. There. So that would be the physical significance. So the scalar dot product gave you a component of one vector and the direction of another vector, and this thing is giving you area. Quite a useful thing. Later on, you will see. You have two random vectors and you want to find an area. Pretty useful, especially in 3D. 2D, most of it you can handle, but once it comes to 3D, it becomes very useful. All clear with this? Great. So let's see a question. We have a bar is 2i minus j plus 3k. B bar is I plus 3j minus 2k. First thing, find A cross B bar. Straightforward, you know how to do that. Area of a parallelogram. Actually, if you get the first one, you get everything. Formed by A bar and B bar. Area of a triangle formed by A bar and B bar. A bar cross A bar minus 2B bar. A bar plus 2B bar dot A cross B bar. Find a vector of magnitude 10 perpendicular to A bar and B bar. There, they should cover most of the models. But the best part, if you got the first part, everything will fall in place. Try. Get the first part. Okay, Anish got something. Yeah, keep doing, Anish. Give it a try. Everyone should try. It's okay if you get a wrong answer. I'll give you another minute and I'll show you the first one. Okay, let's see the first one. So you want A cross B bar. I cap, J cap, K cap, 2, -1, 3 should keep the C. Since A is coming first, you should put A ka coefficients first. This would be I cap, that is 2 -9 minus J cap -4 -3 plus 1 -7 I cap plus 7 J cap. Interesting. 7 K cap. All about that 7. See where it went wrong in case you messed up. What is a B part? You're asking area of a parallelogram. Simply mod of A cross B. So the magnitude of this will be root over 7 square plus 7 square plus 7 square. That's 7 root 3. That's what I said. Once you get 1, you'll get everything else. What is the area of a triangle? Half of this. Which is 7 root 3 by 2. I hope everyone got till here. ABC are like this. Can you do the remaining 3? Give it a try. I'll give another 2 minutes. We don't consider area as a vector, right? That's why, what did I say? Area is mod A cross B. Right, Rohit? Area is not A cross B. Area is mod of A cross B. So when you put a mod, what happens? It becomes a magnitude, right? It won't matter. We consider area as a vector, but for now we are just finding the magnitude of an area. Like I said, later on we will see when the area actually is useful as a vector. Right now, no. 0. For what? D. Okay, get D na first of all. वो छोड़ के E पे क्यों गया? Go in an order. What is the answer for D? Oh, that you typed already. Okay, okay. Try. Others, give it a try. Okay, let's see the next one. You're saying A cross A minus 2B. Now, one way to do is find A minus 2B and do the dot product. There is a better way. A cross A bar minus 2B. Multiply this. So this would be A cross A bar minus 2 times A cross B bar. What is A cross A bar? 0, because like vectors will give you 0. So this is simply minus 2 times A cross B bar. I already know A cross B bar, so minus 2 into minus 7i plus 7j plus 7k. There you can multiply and that's your answer. Easy. So there is no need to find A minus 2b and then do the dot cross product and all. That's lengthy. This is faster. Same thing you can do with E. E is also interesting. See, A bar plus 2b bar dot A cross B bar. So I can write this thing as A bar dot A cross B bar plus 2 times B bar dot A cross B bar. Now, if you remember in the beginning, we said something. If you have two vectors A bar and a vector B bar, this vector A cross B is a pseudo vector which is perpendicular to both of them. Basically, it goes out of the plane. So this is perpendicular. This is also perpendicular. A cross B is perpendicular to both A bar and B bar. And dot product of two perpendicular vectors is 0. So therefore, A bar dot A cross B is 0. Similarly, B bar dot A cross B is 0. So therefore, this is 0. Clear this. So you can actually generalize this, okay? You can say x of A bar plus y of B bar. So this is any random vector in the plane of A bar and B bar. And if you do this with A cross B, this is 0, where x and y are any numbers. So you can generalize this. So again, there's no need to solve for the E part. So A cross B bar is perpendicular to any vector in the plane of A bar and B bar. Clear with this? And this should give you the hint for the last one. What is the last one? He's asking, find a vector of magnitude 10 perpendicular to A bar and B bar. And just now we said A cross B is perpendicular to A bar and B bar. So for the F part, indirectly what you're asking, you want a vector perpendicular to A bar and B bar of magnitude 10. So you're saying I want magnitude 10 and you want in the direction of A cross B bar. How to get a direction? You need a vector mod of A cross B bar. Make sense? So take A cross B bar ka unit vector and plus or minus 10 because it can be up or down. Substitute there and you'll get your answer. So that would be how much? Minus I plus j plus k by root 3. I hope all are clear with this thing. So this covers all the models there, like vector cross product. It can be plus or minus. Previous part of D, here D. Clear? All clear with this? Let's see one more on this. Let's say we have 3 points in space, 3 comma minus 1 comma minus 1. B is 2 comma 3 comma 2. C is minus 1 comma minus 3 comma minus 2. So there are 3 points in 3D. So find area of the triangle ABC. So if you take 3 points, they'll always form a triangle. And if you join them, you get a triangle, find the area of the triangle. How will you approach this? Okay, listen, what are the catch? So we have 3 points in space. So let's call this thing A, let's call this thing B, and let's call this thing C. And you're saying they're forming a triangle. Great. So can I say like this? If I just join them, so this triangle has two sides. So this is AB bar and this is AC bar. Do you guys remember that formula, area of a triangle? So in the formula, area of a triangle, what are A cross A and B bar? They are the sides of a triangle. So in the formula, area of a triangle, which is half of mod A bar cross B bar, A bar and B bar are sides of a triangle. That means in our problem now, the sides are AB, AC or BC. You can actually take any two sides, huh? You will get the same answer. So here area will be half of modulus AB bar cross AC bar. Making sense? So in the formula, A bar and B bar are sides of a parallelogram or sides of a triangle. So I had to get sides of a triangle. You could have taken BC and AC. You will still get the same answer. Can you do this now? You know how to do AB bar. You know how to find AC bar. So what's AB bar? A to B. So B is final, B is initial, minus I cap. 3, that is 4J cap. Then 3K cap. AC bar minus 4I cap. Minus 2J cap. Minus K cap. I need to get a cross product for this. Let's see. Get it fast, everyone. You guys know how to do the cross product. So that's the main idea there. If I give you some random points in the space, it's like I said, it's difficult to visualize how the triangle will look, but your vector cross product will take care of it. Okay with this? Any answers? Anish got something. Dhruv, we need to get the magnitude. Hmm, Rohit, magnitude. It's a mod of AB cross AC bar. Okay, let's see. Why are you guys struggling so much with this? Or you will tell the answer. That would be minus 4 plus 6. 2I cap minus J cap. So 1, 12, 13. That will be 2, 18. Got this? Then I think the magnitude will turn out to be root 497 by 2. I think two people got it. You can verify from here. Clear with this? So that's it. The main idea is to figure out AB bar and AC bar are the sides. Once you got that, you're done. Clear? That's about vector cross product. So there's nothing much on that. The main thing was to solve that matrix. The next thing is the box product. I know this is the last one. Don't worry, there are no more products. So what is a box product? So we represent this like A bar, B bar, C bar. So we call this thing as box ABC. That is how we pronounce it. So this is nothing but a combination of A cross B dot C bar or B cross C dot A bar. So it's a one cross product and one dot product. C cross A dot B bar. All are same. You'll get the same thing there. So what does this exactly mean and why do we call it a box? Consider a three-dimensional parallelogram. So a three-dimensional parallelogram is called a parallelepiped. Parallelepiped. It's like a square becomes a cube. A rectangle becomes a cuboid. A parallelogram becomes a parallelepiped. Formed by A bar, B bar, and C bar. So if you take these three vectors, so if this is your A bar, this is your B bar, A bar, and B bar. Now if you put four C bars, so these green ones are your C bars. And again, you put A bar, B bar, and C bar. You can clearly see this forms a parallelepiped. That's why we call it a box. So this is your base area. So A cross B is the base. So the volume of this parallelepiped, we'll see how we got this. So now if you see something, right, you will notice the scalar dot product gave you a length along a vector. It gave one dimensional. A vector cross product gave you area, two dimensional. Box product is giving you three dimensional. So volume of a parallelepiped is given by box ABC. If you want to find the volume of a 3D thing, a parallelogram, this is the formula we have to use. We'll see how to calculate, but let's see how to get this. Box ABC, which is A cross B dot C. But did everyone understood how we got a parallelepiped, the three-dimensional thing? No. Let me just draw it again. So we have A bar. So this is your C bar. Now see, how does A cross B bar? A cross B bar is perpendicular to both A bar and B bar. So this is your A cross B bar. And this is your angle alpha. And when you drop this perpendicular, this height will come out to be C cos alpha. So this box which we have created has a height of C cos alpha. So what is the volume of a parallelepiped? A base area into height. And what is alpha here? Alpha is the angle between C bar and A cross B bar. Now if you combine this, so the base area is A cross B bar, height is C cos alpha. Now, if you look at this, doesn't this kind of look like mod P, mod Q, cos theta? Kind of, doesn't it look like that? C bar, D bar, cos theta. So I can write this thing as P bar dot Q bar. But P bar ka place mein we have A cross B and C bar ka place mein we have C. So that's A cross P dot C. That is a proof for this. Clear with this. So the base area into height will give you the volume of a parallelepiped. So put just a mod for this. So this is the volume of a parallelepiped. That's your first formula. Next thing, what if the box product is 0? If A, B, C is 0, what does it imply? This implies volume is 0. But what does that mean? This means there is no box only. If all the vectors are in the same plane, then you cannot form a box. Such vectors are called coplanar vectors. So this is a very good condition for this thing. This is a condition for coplanarity. How do you prove three vectors are in the same plane? See, if 3 points are in the same line, we call it collinear, isn't it? If 3 vectors are in the same plane, we call them coplanar vectors. So this is the condition for coplanar vectors. Box product must be 0. You might think like, oh, okay, so what are these things exactly? You have seen this, huh? But I'll show you the next page. Have a look at this. Everyone is clear? Why are we getting volume from here? Tanmay, Srikanth, Rohit, Ishi. Clear? You know where you have seen this thing? Again, in optics, you must have studied this. The incident ray, the reflected ray, and the normal are in the same plane. You guys remember the statement? In law of reflection, there are, I think, 3 points. One was the angle of incidence is equal to angle of reflection. The second thing was the incident ray, reflected ray, and the normal are in the same side of the mirror. Third was they're in the same plane. If they're in the same plane, that means they're coplanar vectors. Incident ray, normal, and reflected ray are in the same plane. That means if you take a box product of I bar, R bar, N cap, you will get 0. So coplanar vectors mean the vectors which are in the same plane. Right, Ahana? Are you there, Ahana? You should be able to draw all of them in a paper. Remember, हमने ये example दिया था. Now see, these 3 vectors are not coplanar. You cannot put them on one paper, isn't it? The tetrahedron wala. So these are non-coplanar vectors, meaning those 3 are not in the same paper or same plane. You cannot draw them. If you try to put 2 on a paper, the third one will go out of the paper. Is that making sense, Ahana? Yeah. So the tetrahedron was a good example for non-coplanar vectors. Great. So how do we calculate this box product? One thing, you can do the cross product, you can do the dot product, but there is a better way, which you already know. We take a determinant. So what is first? A, right? So AX, AY, AZ. Next is B, BX, BY, BZ, CX, CY, CZ. There. You just do a 3 into 3 det. Just put all these things and then you're done. Tetrahedron will be half. I think it'll be 1/4. I think the cube is made of, you can make of 2 tetrahedrons, I guess. That I didn't think about it. All clear with this? Great. So let's see a question on this. Now everyone knows how to do the box product. The name looks scary and all, but yeah, you already know how to do this. So A bar is 3i minus 2j plus k cap. B bar is I plus j minus 2k. C bar is 4i minus j plus 2k. So first thing they'll ask you, find box product ABC, which is A cross B dot C. You know how to do the matrix. Find volume of the parallelepiped. So the thing is, you just do the first one, all the things will come. Third, are these vectors coplanar? So there'll be a question like this. So if you got the first one, you can answer B and C also. There, let's finish off. Any answers? We have one answer from Manish. Finish off. Last one for the day. Like, we are done with the chapter. That should give you some energy. Fast. Right, Ishi. Nedru. Let's see. Box ABC, coefficients 3. Just try to be careful with the signs. Like one sign, everything will go for a toss. 3, minus 2, 1, 1, 1, minus 2, 4, minus 1, 2. Plus, minus, plus. That will be 3. That will be 2, minus, minus 3 minuses are there. So that is 2 minus 2, that's 0. Interesting. Then minus of minus 2, and that is 2 plus 8, that's 10. That's 1, and minus 1 minus 4, and that's 15. So that's your box product. So what is the volume? The box product, 15. So like I said, it's like there are 3 questions, but the answer is same. Are these vector coplanars? No, they're not coplanar. They're non-coplanar vectors. Because the box product is not 0. That's it. That's a simple proof. If you got 0, then they're coplanar, and you're done. Yeah, you can do A cross B dot C. That also works, but if you didn't get it, then your answer is wrong. You need to check where it went wrong. All clear with this? With that, we are done with vectors. They're almost 35 questions, 187 pages. So that's how it goes. I think this 35 questions did not include the basic max questions. Vectors only we did 35. So please make sure to go through this, right? I think last time I sent you a sheet. I'll send you a sheet anyway. So you can start doing, like, if you're doing your booklet, if you're doing DCP or HCV or my booklet, you can start doing it. Right. And next Wednesday, when we catch up, we'll be starting with a new chapter, calculus. We'll be starting with differentiation and then integration. Even though it is not a physics chapter, right, it's very important. Advanced may half the questions will be calculus based. Like, you should be very thorough with calculus. Again, it is just a mathematical tool. So the thing is, max people will teach you calculus next year around April, May, around this time. It will be too late by then. And they will teach you much, much higher level. We don't need that much. It's not a big chapter, but yeah, we have a lot of variations in that. So it should take around 2.5, 3 weeks. So 3 weeks the minimum it will take. And then we'll start off with kinematics after that. Okay, with that, we'll wrap up for the day. And like I said, I hope everyone has enrolled in that testing platform and you have seen that sample test. So just get familiarized with it. So this Saturday, the test will be online. I already posted this thing. So first 1 or 2 tests will be like standard basics. So don't worry too much. So just go there, give a test, get used to it. Okay, with that, we'll have a further day. I'll see you on Wednesday, same time. So any doubts, anything else, please stay back and ask, or else you're free to leave.